Hey, thanks for joining the hybrid virtual event today. I'm Travis Wright, the Group PM Manager for Azure Arc Enabled Data Services, Azure Arc Enabled SQL Server, and our machine learning capabilities across SQL Server and our Azure Data Services. I'm really excited today to talk to you about Azure Arc Enabled Data Services, which is part of the bigger announcement that we made at Ignite about Azure Arc. Azure Arc is how Microsoft is enabling our customers to extend the management capabilities of Azure out into managing their servers and services running in their own infrastructure, whether that's in your own data center or an edge site location like a retail store, or even in other public clouds. It also enables you to run these data services that we have in Azure in your own infrastructure. The Azure data services that we provide in Azure, like Azure SQL Managed Instance or Azure Database PostgreSQL, really deliver a lot of operational efficiency to customers. There's automatic built-in self-service provisioning, automatic backup and restore, automatic high availability, built-in monitoring. The idea is to take that same level of operational efficiency that we have gained as Microsoft and the Azure team operating those services on behalf of customers at a scale of millions of databases with just a small team in Redmond. Take that operational efficiency and deliver that to you so that you can operate with that same level of efficiency in your own infrastructure. So to begin with, we're starting with Azure SQL Managed Instance and Azure Database PostgreSQL Hyperscale as the two data services will enable you to run on your own infrastructure with Azure Arc. In this session today, we're going to go through a series of demos that really are designed to just show you the product, how you can get going with it. The first demo will show you how we deploy the Azure Arc Data Controller. The Data Controller is really the heart of Azure Arc Enabled Data Services. It provides all of those management capabilities of self-service provisioning and deprovisioning, scaling, monitoring, backup restore, and even things like automated software updates to all those database instances you have provisioned. The data controller deployment is really pretty straightforward. As you'll see, it's just really one command that you run to deploy a series of pods onto your Kubernetes cluster so you can begin deploying and operating your SQL and Postgres instances. The next demo we'll show is actually how you can use the data controller to provision a SQL instance into your environment. And then I'll show you how you can do an operational task like a backup restore of a Postgres instance. And then lastly, we'll show you how you can do local monitoring and even take that monitoring data and send it up to Azure Monitor so you can see it in the Azure portal and monitor your database instances at scale across potentially many different environments. So to begin with, let's go ahead and dive right into how we deploy the data controller. Okay, so to begin with, I just want to show you how I'm already connected to a Kubernetes cluster. So I can do a command like kubectl cluster info. And you can see that in this case, I'm connected to a Kubernetes cluster up in AKS in Azure. So I can do something like kubectl config current context. And you can see that I'm connected to that Kubernetes cluster right there. I can do something like kubectl get nodes. I can see the nodes that I've got up there. So I've already got this connection established to my Kubernetes cluster. And now I'm ready to start deploying the data controller into my Kubernetes cluster. Now, out of the box, we provide some configuration profiles that are pre-configured for certain types of environments. So to see what I'm talking about here, I'm going to run AZData control config list. And this will show me all of the default configuration files that we provide out of the box. And I can just use any one of these that are maybe already pre-configured for how I want to connect to the Kubernetes cluster. Or I can make a copy of one of these and tweak some of the settings if I want. Now, in this case, I'm just going to go ahead and use the one that's already been predefined for using an AKS. But you can see we have some other options there, and we'll add some more over time for other types of Kubernetes clusters like OpenShift, for example. So to begin with, to deploy the data controller, what I do is I run AZData control create -n, and I give it a name and a -c, which is for the configuration profile. And I just run this command, and that's it. It's pretty straightforward. This is now going to use my existing connection to the Kubernetes cluster that we saw earlier to connect to that Kubernetes cluster. In this case, it's AKS cluster up in Azure, but it could be any Kubernetes cluster running in my data center or even another public cloud. And it will start to provision all of the pods onto that Kubernetes cluster that make up the data controller. So let's go ahead and kind of see what happens here. It says starting cluster deployment. So in here in another window, we can actually go see what's going on. So we could run something like kubectl get namespace, and we can see that there's already been an Arc namespace created here. And I can run another command like kubectl get pod -n arc, which will give me all of the pods that are in that Kubernetes namespace. And you can see that it's already brought up the operator pod, and it's now in the process of creating the control DB pod, which is the configuration database for the data controller, and the control pod here, which is the controller API pod. So as these pods are coming up here, we can sort of just keep an eye on the status of these and see how it's going. Now, just to sort of fast forward things, I'm going to pivot back over here to this tab here, and you'll see that the command output will happen here, and then sort of through the magic of pre-recording this particular demo, we'll be able to fast forward through this because it takes about 10 to 12 minutes to deploy the entire data controller, including all the download time for those container images to come down to the cluster. So at this point, we can see that the cluster controller endpoint is now available. So this is the API that AZ Data will connect to operate the data controller as we need to. So if we go and run get pod, at this point, we'll see that these pods are now all up and the deployment process is moving on to the next stage here. Okay, so at this point, we can see that all of the resources have now been provisioned. We can pivot over here to run a get pod again, and we can see that all of these pods now have been provisioned. So, in addition to the controller API pod and the controller DB pod that we saw earlier in the operator pod, we now have this watchdog pod that looks over the data controller API and database. We've got the logs database where we store all the logs that are collected across the system, the logs UI, which is where we can do log analytics using Kibana. And then we have the metrics database, which is an influx database used to collect metrics about everything going on in the system. And we have metrics UI here, which is the Grafana interface for doing dashboarding on top of that metrics database. And then we have a daemon set here that collects metrics off of each of the 3 nodes that we have in this Kubernetes cluster. And then the management proxy, which sits in front of the metrics UI and logs UI as a proxy web interface for us to connect into. So we can also do things like kubectl get service, and we can see the services that are automatically created for us. So we can see that because we're deployed into an AKS cluster here, that the controller service API is exposed externally outside of the cluster at this IP address here, and the management proxy is exposed externally outside the cluster at this IP address. So at this point, we are fully deployed, the data controller is up and running, and now the next step for us to do would be to log into the data controller by running AZData login. And this will prompt us for which namespace to log into. So we type in Arc here, we type in the username and password to connect, and now we are connected to the data controller. And now at this point, I can start to take other actions, which we'll see in some of the demos coming up here in a minute. Okay, so we saw how easy it was to deploy the data controller. Just one command, boom, drops a bunch of pods onto the Kubernetes cluster, and we're ready to go. In this next demo, I'll show you how we can deploy the Azure SQL Managed Instance into that Kubernetes cluster. I'll show you 3 different ways of doing this. The first is using the CLI, AZ Data. And this is really great for operational efficiency because you oftentimes want to provision these things in an automated way, maybe as part of some sort of continuous delivery pipeline. The second way I'll show you is through Azure Data Studio, which is our GUI tool, which runs on Windows, Linux, or Mac. It connects locally into your environment so you can deploy and operate your SQL and Postgres instances there locally with that GUI tool. And the last way is if you have an Azure Arc enabled Kubernetes cluster, you can actually provision these SQL and Postgres instances from the portal in Azure onto your Kubernetes cluster on your own infrastructure. So let's go ahead now and take a look at how we can deploy an Azure SQL Managed Instance. All right, so in this next demo here, I'm going to show you how we can actually provision a SQL Managed Instance into our Kubernetes environment in a variety of different ways. The first way I'll show you here is using the AZ Data CLI. And then I'll also show you some experiences using Azure Data Studio as well as the Azure portal. So to begin with the AZ Data CLI, I've already logged in. So now I can run a command like AZ Data SQL Instance Create, give it a name, the number of cores I want it to have, what subscription it should be in, what resource group it should be in, and which Azure region the metadata about this instance should be stored in. And with that, I can just run this command, and it's going to prompt me for the SA account password. So I'll enter that. And this will then now reach out to the AZ Data API, connect to that, and instruct the data controller to provision a new SQL instance onto that Kubernetes cluster as a pod. And this takes just a few seconds here. So while that's happening, I want to show you a couple of other ways that we can do it. So one other way we can do it is using Azure Data Studio. So in Azure Data Studio here, this is our cross-platform GUI tool, runs on Windows, Linux, or Mac. It's open source, all the code's up on GitHub. Anybody can contribute to it. It's designed to be extensible. And it's really a multi-persona tool. It works really well for data engineers, database administrators, developers, data scientists. So in this case, what I'm going to do is I'm going to use this tool to provision a SQL instance onto my Kubernetes cluster. So I'm going to go here to New Deployment, and I'll choose Azure SQL Managed Instance. Check this agreement here, and then select. And this will bring up the panel here where I can provide the information like my Azure subscription, resource group, and Azure location like we just saw on the CLI. And then I can provide the username and password here. And that's how I can provision an instance into my Kubernetes cluster using more of a GUI experience here. Now, the last experience that I'll show you is the Azure portal experience. So if I go up here to the Azure portal and I then say I want to go into the marketplace where I would normally go to find things that I want to provision, I can type something like Arc in here to find the available Arc services. And we can see here that we have the Azure Database for Postgres option and the Azure Database Managed Instance option here. So I'll click on the Managed Instance option here, click Create, and this will bring me to a form that looks very similar to what we saw before, where I can choose my subscription and resource group. I can provide an instance name and the Azure region where the metadata should be stored. And here in this Arc location is all the data controllers that I have provisioned in this subscription. This subscription doesn't really have one right now, but those would show up here, and that's how I could target my deployment from the Azure portal to be pushed down to be deployed onto that Kubernetes cluster. And here's where I would provide the admin username and password, and I just simply hit review and create, and it'll push a SQL instance out onto my Kubernetes cluster right here from inside of the Azure portal. Now, all of these are just different options that you have. If you are running your data services in an environment which you do not want to have connectivity back up to Azure, that's fine. You can run it in that sort of lockdown or disconnected environment, and you can use just the AZ Data CLI tool or the Azure Data Studio tool locally to connect to the API for the data controller and manage everything locally without any connectivity to Azure. Okay, so let's go back and check on our instance that we provisioned through AZ Data. Looks like that was provisioned. So we can see here that the instance is now ready at this IP address and port number. And we can see that this resource has been created up in Azure as well, SQL Demo 0. Now, if we look at this, we can see that there's a pod here in our namespace for SQL Demo 0. So this is the actual SQL instance that's running here. We can do a kubectl describe on this pod and see all the details about it. So in this particular case, this pod has 3 containers in it. The first one is the MS SQL container. This is the actual SQL engine running right here. And then we have a collectd container running inside of there as well, and that's used to collect the metrics about the system. And then we have a FluentBit container, which is used to collect the logs about the system and send that information into the Elasticsearch database, and then we can search on it through the Kibana UI, which we'll see here in a minute. Now, we can also take a look at things like what the services look like. So we could run a kubectl get service, And we'll see that there's another service that's exposed right here for SQL Demo 0, and this is the IP address at which it is available. And we can also run an AZData command to get this kind of information as well, which is AZData SQL Instance describe SQL Demo 0. And this will show us kind of all the details about this particular instance. And that way it's just kind of an easy way that if I'm not a Kubernetes native person, I can use the AZData experience, which is familiar to Azure users, to get this kind of information. I can also run a command like AZData SQL instance endpoint -n SQL demo 0. And this will show me all the different endpoints for that particular SQL instance, so I know where to connect to. In this case, I can get the connection to the front door of the SQL instance, so I can connect to it and do all my usual T-SQL types of commands. Or these are the URLs where I can go and look at the Grafana or Kibana dashboards for the metrics and the logs. Now, the Azure resource was also created, if you remember, right? So now if we go back up here to the Azure UI and we search for that resource, we will find that resource up here in Azure. So we click on that resource and you can see that this resource has been created right up here inside of Azure. So now I can manage this resource from inside of Azure, just like I could any other resource in Azure. So I get sort of a dashboard view about this instance. I can see how to connect to that instance here. I can see which resource group it's in, which subscription it's in, which Azure region has the metadata stored in it about this resource. And then things like activity log and access control and tags, these are just base sort of functionality provided by Azure Resource Manager, and they apply to these SQL instances just like any other resource inside of Azure. But then there's some data instance specific capabilities here, like where I can configure the updates to be applied to this particular instance, either on an automated schedule, or I can choose when to trigger the automated deployment of those updates here. And I can also turn on advanced data security easily by just going to this panel here, turning this on and hitting save. So a lot of this experience should be very familiar to anybody that's familiar with using Azure to manage their database instances inside of Azure. And now you can use that same familiar experience to manage your database instances that are outside of Azure infrastructure. Maybe that's in your own data center or in an edge site location or even another public cloud. All right, so there we go. It was very easy to deploy that SQL Managed Instance into our Kubernetes cluster. We saw a few different ways of doing it. Just depends on what you're trying to do, whether you're trying to automate it or it's just sort of a thing you want to do through a GUI tool or through the Azure portal. Now, I want to switch gears here a little bit and sort of switch into more of a day two operations mode here. We've got that instance deployed. How do we provide the care and feeding for that database instance over time? So as an example of this, I want to show you the backup and restore capabilities. But this time I want to shift from doing something with Azure SQL Managed Instance, and I want to show you how we can do that with PostgreSQL Hyperscale. Now, the thing about this Postgres is it's not just regular Postgres. It's actually a special distribution of Postgres that is 100% compatible with the open source version of Postgres. But we've extended it with a special extension which enables a scale out architecture for PostgreSQL. And the way you do that is you take a series of tables and you can designate those as sharded tables, and Postgres will automatically distribute that data across a bunch of servers. So you can actually scale out and really boost your performance a lot that way. But of course, that gets a little tricky when you try to back up a database. So how do we do that? Well, I'll show you that the experience of that is very simple, and it's also equally simple to restore a database like that. So let's dive right in. All right, so taking a backup is really straightforward. We just use AZData CLI again to take a backup here. We're going to run AZData Postgres backup take, and we specify the name of the Postgres instance that we have, the namespace in which it is, and the backup name that we want to create for this backup. So just go ahead and execute that command, and that just takes a few seconds or minutes, kind of depending on the size of the Postgres instance. Okay, so now that our backup is done, we can now list the backups that we have available like this. Now we should be able to see that we have a backup here available named demo. And now if we want to restore that backup, we just sort of do the reverse of take here and we do restore. And just like that, we can just restore a backup back to that point in time at which we created that backup. So, again, this is designed to be just very straightforward and automatable using the AZ Data CLI. You just go in and take a backup, see which backups we have available, restore back to a given backup that we've taken, and it just is that simple. All right, so there you go. We saw how to back up and restore a PostgreSQL Hyperscale instance. You can see that the experience of it is very simple. Even though we're behind the scenes backing up a database which is distributed across multiple servers and then restoring it back across multiple servers, the experience is very simple, and it's exactly the same as the experience you'll see for a SQL Managed Instance as well. So the idea is to give you a consistent experience regardless of which database instance you're using, Postgres or with SQL. Now let's switch gears a little bit and go over and talk about the monitoring experience. With monitoring, we want to make sure that everything's running smoothly. We've got plenty of CPU cycles and memory and disk storage and so on, and that our query response times are super fast. So to do that, Azure Arc enabled data services provides a local monitoring capability. We have agents that are deployed with each of those SQL and Postgres instances that collect the monitoring data back to an Elasticsearch database for the logs, to an Influx database for the metrics. And then we put Kibana on top of Elasticsearch for doing log analytics, and we put Grafana dashboards on top of InfluxDB to give you a monitoring dashboard of all your metrics. Now, in addition to that local monitoring experience, we've also given you the option to integrate with Azure Monitor, so that you can send all of those logs and metrics up to Azure Monitor and use Azure Monitor as a point of aggregation. Let's say you have a data controller deployed in 5 different data centers and maybe a bunch of edge site locations like your retail stores. You want to bring all that data together into one central place so that you can see that data in one place inside of the Azure portal and leverage Azure Monitor and the other Azure services like Azure Machine Learning Service in Azure to help you monitor things and do things like alerting and notifications off of Azure Monitor. So let's go ahead and take a look now at what this local monitoring experience looks like and how we can send that data up to Azure Monitor. Okay, so at this point, our SQL instance has been running for a little while, so we've had some logs and metrics be collected about it by the data controller and stored in InfluxDB and Elasticsearch, and now we should be able to visualize that through Kibana and Grafana locally. All of this monitoring happens locally. So to do that, let's run that AZ Data SQL Instance endpoint command that we did earlier. And we'll get all the endpoints for that SQL instance, including the URL at which we can go and see the information about that instance for the logs. So we can just run that command there. And this will bring up the Kibana UI here. And we'll log in with our same credentials we used for the data controller. And this brings up the Kibana UI, which, if you're familiar with that, should be pretty straightforward here. So here we can go into this dashboard here where we can discover things, and we can do a search for maybe all the log entries that were about SQL Demo 0. So we just type that in here and we can see all the different log entries that happened about SQL Demo 0 here. And if there was some particular thing that we wanted to search for, we could search for something. So let's say we want to find all the log entries that had this controller word in it. We can just go and put that up here in our search box, and we'll find just the log entries that have the word controller in it and SQL Demo 0, right? So that way we sort of really quickly dive in and see across our entire system all the different instances that might be having a particular error message, when it's happened over time, and so on. So now let's go look at the Grafana dashboard. So we just grab the metrics dashboard URL here, and we just run that here. And this will prompt us for the credentials again. So here's the SQL Demo 0 dashboard. So we can see all the metrics about the SQL, the transactions per second, batch requests per second, wait stats. These are kind of all metrics that are pretty typical to keep an eye on for a given SQL instance. But we also have dashboards for other things. We've got, for example, the Postgres dashboards here. So we can keep an eye on Postgres specific things. This is the PG1 instance we were just backing up a little bit earlier. We also have dashboards for the nodes. So we can go in here and we can actually see the resource utilization of each of the nodes. Here's my 3 nodes in my AKS cluster. We can see details about CPU utilization here. You can take a look at memory and process utilization and so on. So lots of granular details that are being collected continuously about the performance of the underlying nodes. So we can see not just the database instance performance and sort of SQL or Postgres specific metrics, but we can also see information in the same dashboards here about the performance of the underlying hardware and Kubernetes. All right, so there you go. You've seen the monitoring experience, which is built into Azure Arc enabled data service, and how simple that makes it for you to keep an eye on things. So today we've seen everything from how you get started with provisioning the data controller through those day 2 operations of provisioning a SQL Managed Instance, backup restore of PostgreSQL, and finally monitoring. There's lots more to explore with Azure Arc enabled data services. So we encourage you to sign up for the private preview at aka.ms/Azure Arc Data, and we'll onboard you into the private preview program where you can get access to the bits, get engaged with our program management team, and just get involved with the other customers that are involved in the private preview, so we can all sort of experience this together, learn from each other, and really refine the product as we go forward into the public preview milestone and eventually to general availability. We also announced Azure Arc enabled SQL Server here today at the hybrid virtual event, so I encourage you to sign up for the preview of that as well, because it enables you to manage your SQL servers wherever they are on physical or virtual machines on any infrastructure from Azure, and deliver a lot of these same kinds of operational automation abilities for your existing SQL servers wherever those might be. So thanks for joining today, and we look forward to seeing you as part of the preview.